This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hello everyone, this is Felienne for Software Engineering Radio. Today with me I have two guests. Firstly, Chris Riccomini is a software engineer, startup investor and advisor with more than a decade of experience at major tech companies and the author of Apache Samza. Also with me, Dmitriy Ryaboy, a software engineer and engineering manager that's worked at a variety of companies and helped create Apache Parquet. He's currently the vice president of software engineering at Zemergent. Together, Dmitriy and Chris wrote the book, The Missing Readme, that is the topic of today's episode. So firstly, a question what is this book about? Who is this book for? Of course, it's called The Missing Readme, but the Readme of what?
First off, thanks for having us on the show. It's great to join you this morning, or at least morning for us. So the book is really for a few different audiences. I think the impetus for writing the book, first off, was a few years ago, I inherited a team of engineers to manage, and many of them were pretty entry level. And so I was doing the normal round of kind of one-on-ones, getting to know everybody and talking about what they're working on and stuff. And I found myself repeating what I was saying quite a bit. And I sort of converged on the idea that there should really be a manual for this to help new software engineers get up and running and off the ground and kind of integrated into the flow of working at a company as a professional. So I would say one of the audiences is actually the managers that are hopefully excited to hand out this book to the people working for them, help them kind of bootstrap new hires and stuff. Our aspiration and actually our intent that, we keep a stack of these under our desk for people as they onboard. If they need to get going, we can help them out with it. Second and main audience, I would say, is really engineers sort of in the 0 to 5 year experience range, either just coming out of college, just entering the workforce. This cohort of engineers has a lot of good computer science fundamental experience. So they've been trained, in operating systems and compilers and programming languages and stuff like that. They tend to have a little bit, painting with somewhat of a broad brush here, but this has been my impression. They tend to have a little bit less experience doing sort of, I wouldn't call it softer skills, but just knowing how a company works and how to interact with a manager, how to interact with other teams, even how to work with a team. Oftentimes in university, you might have some projects that you do with some of your students, but a lot of your work is done in isolation. And of course, when you join a company, almost all of your work is not done in isolation. It can be a little bit disorienting. So that's, I would say, the second audience. And then the third audience is somewhat similar, but I think has sort of the inverse skill set of a new college grad. And this is boot camp type engineers. So people that have, maybe 0 to however many years of real world work experience, but in perhaps a different field. So these, we've hired boot camps at WePay, the company I currently work for, boot camp graduates that have come from, there were lawyers. We had somebody that we hired that was an editor, like a book editor. They often have a fairly broad skill set and also experience interacting with managers, working at companies, understanding how things work in a little bit more detail than perhaps your new college graduate might. But on the other hand, they tend to have a little bit less on the CS fundamental side of things. So whereas a new college graduate has, 4 years of class after class after class of CS fundamentals, a boot camper might have 6 months of intensive training, oftentimes in kind of a full stack environment. And they get trained up in one language or 2 languages, and then a stack of some sort, whether that's Node or Python or something like that. And so the book kind of somewhat ambitiously tries to cover all this, but it's not meant to cover it in super deep detail. And so what we do is we cover sort of a lot of the technical stuff that you wouldn't get taught in a university setting. So this is some of the details of modern testing, how you interact with legacy code and work on refactoring and stuff like that, how you do operations. So new college graduates are not often taught how to be on call. And it turns out when you go into the workforce, oftentimes you go on call and you get paged and you have to answer questions and nobody really tells you how to do this. So there's sort of a technical portion of the book. And then there's a more process-oriented portion of the book that's about managers and promotions and even design discussions, stuff like that. So it's meant to address sort of both of these audiences.
That's a great answer. Such a diverse book that covers different skills. And of course, me working at a university, sort of part of your audience is coming from my pipeline. So I very much recognize this. Well, you teach them CS fundamentals, but there's so much more to know.
It's exactly that. There is, just to add to what Chris was saying, most of the time, the way people learn how to code and the way they get into their first software engineering job, it's working on their own project, and they don't really get to see the work of maintaining the code and working with the team to keep it running, right? So you get sort of this very nice, clean, sort of, maybe you have an exercise where there's an existing piece of code and you need to modify it, and that's great, but then you modify it and you're done. You submit your assignment, you get your grade, you never look at it again. Whereas when you're working on something, you're just looking at the thing all the time, and other people are looking at that thing all the time, and it's evolving under you. And it's a different mode of working, and a lot of the things that we spend time on in the book are about sort of the practices that have developed within the industry for dealing with that. And you just don't really get that experience either in college or in boot camp. And often you don't know what you don't know. And in terms of the genesis of the book, I had a similar experience to Chris. By the way, like, Chris and I have never actually met in real life.
Wow.
Although we've sort of known each other on the internet for a decade or so, but the experiences really parallel each other. New people join and they know how to program. They have maybe they have experience from other things, but there are certain things where they don't even know what you're talking about when you start talking about it. And to somebody who's been around for a while, it's so second nature, we don't recognize it as a topic to teach because it's not algorithmic complexity, or clever ways to traverse a binary tree or whatever. Like, those things are obvious that, like, there's a thing here, you need to learn it. How to do logging well is just logging, right? But actually it's really complicated.
Yeah, I think we will definitely get to logging and more practical skills. But firstly, I want to go back to one of the things you also talk about that you were just hinting at is the idea of technical debt, right? That indeed in university or in a boot camp, you make an exercise and maybe you change code, but definitely you will not be given 10-year-olds, a million lines of 10-year-old C code. So I think what I really liked about your book is that you describe two different forms of technical debt that to me were new, prudent and reckless. So maybe you can dive into a brief summary for people in the audience that might not know at all what technical debt is, but specifically prudent and reckless, and what do you think that distinction adds?
Prudent and reckless technical debt. This is an idea we got from Martin Fowler, who has a really informative website, martinfowler.com. He describes a matrix of the kinds of debt you might take on. So it's your standard 2x2. So on one side you have deliberate versus inadvertent, and on the other you have reckless and prudent. And so you can have any combination of those two, right? So you might have something that's reckless and deliberate, so you're deliberately being reckless, or you might have something that's reckless and inadvertent. We get into it in the book, but essentially you consciously make a decision to take on some debt, and you have a plan for how to address it, or you consciously make the decision that this is a risk we're willing to take as you kind of evaluate it. And then there is inadvertent, when you don't know what you don't know. And maybe you do it so reckless and inadvertent is, I don't know what's going to happen, but we just got to go, and you just write some stuff and you throw it out there, and then you have problems. Or you have prudent and inadvertent, where you know there's an unknown and you need to move forward, and you say, here's how we're going to monitor this to learn more. And when we learn more, inevitably, we're going to do something about it. And the fact is, that especially that kind of debt is unavoidable if you're going to make any forward progress, right? As we start building a program, as it starts being used by real humans, you find out more about the problem, and then you learn how maybe you should have solved it, right? And then now you have technical debt, but you couldn't have addressed it before you started writing. And in fact, the definition of technical debt, that kind of the original definition where the term came from, is about that, about learning. The original term came about from trying to explain to sort of non-technical people that sometimes we got to write the thing and it's not going to be quite right, because through the process of creating software to solve this problem, we're going to learn more about the problem and we're going to understand it better. And that's why we always need to revise, right? That's why it's not write once and it's done. It's usually write it, improve it, keep improving it. It keeps living and changing.
Because I think this is such a useful distinction, especially indeed for people that are new, that don't really understand how to do something. And then you want to communicate, like sometimes it's okay if you don't understand how to do something, but sometimes you can make some predictions. One of the things you advise in the book, sort of against technical debt, to pay off technical debt, so to say, is to do minor refactorings, like make small fixes. So I was wondering, like, where does that advice come from? Because I can imagine that making small fixes can also be like, oh, a bit of duct tape here, oh, a tie wrap there, and then, you build this bigger monster. Isn't that sort of conflicting with creating more reckless technical debt? How do you see that?
In practical experience, addressing technical debt takes a lot of different strategies. So it really is dependent on the kind of technical debt you're dealing with, and if you know what to do about it, right? So there are certainly some cases where it's appropriate to do large scale, like refactoring efforts. Those are really complicated and really hard to get right. I have seen them done correctly, but it usually requires the entire organization like grinding to a halt before there's an appetite to do that. So oftentimes you find yourself having to do things incrementally, whether it is an ideal state or not. And in some cases it is an ideal state. So I think when you're doing smaller refactoring, there's kind of two kinds of debt that you can address with that mode. One is like minor cleanup kind of stuff where it's not a systemic problem that you're dealing with, but it's something that's limited and maybe more isolated. So maybe there's some utility class that needs to get refactored and everyone knows it needs to get refactored. You're, mucking around with it. You might decide that this is something that I'm going to take on. It's fairly minor. I can do it in, a day or two. And I think as long as that's handled appropriately and the commits are separated, so it's not intermingled with your regular feature work, you can be pretty successful with that. The second kind of technical debt approach is where you actually know the long-term, like what the end state that you want to get to, and you can march toward it incrementally. That's like the ideal, right? And so, for example, with my own teams, we will sort of have an escalating approach to technical debt where on the first chunk, we have sort of the minor stuff that we do as we're working. And usually we'll budget a bit of time to do some of that work. But the second step up from that is like, there's a project that's like maybe a quarter that we can budget in. And the third one is sort of like that very large chunk of work.
Yeah. And in addition to what Chris just said, the reason we make a point of talking about minor refactoring is that it's very easy to get into these dichotomies of people saying, just don't touch it. And, unless you're really, really ready to tackle it, leave it alone. Or, just got to burn it down and start it all over. Like, let's re-architect the whole thing. We're going to switch languages. There's a new framework on Hacker News, so let's adopt that. You can make things better by just fixing them as you go along. Like, while you're in there, you see that, the API, some internal API is not quite right, or there's inconsistency in how certain libraries are used, or something needs to be upgraded. Just go ahead and do it. It doesn't need to be a giant big deal where, it's prioritized by all the managers and there's a committee that decides when to do refactoring. Like, you see something that's a little broken, you can just fix it. It's okay. Especially when you're inheriting the million lines of C code type thing, where it'll just take a while. The little things do add up, right? As long as there's, like Chris was saying, as long as there's agreement about where you need to take things and you're not just changing so that now there's 17 different coding styles in the same code base, you don't need to stop the world and sort of redo the whole thing, right? Like, you can do it a chunk at a time as you go along.
Yeah, I think that's really good advice, because indeed, if you wait for this perfect opportunity in which there will be no feature requests for 3 months, that clearly is never going to happen, right? So I totally understand you need to do this step by step. So you actually, in the book, you describe sort of an algorithm, so to say, to deal with legacy code. Maybe you can summarize that and explain the background of that too?
Sure. This also isn't something that we came up with. Most of the ideas in the book are borrowed. So this is the legacy code change algorithm from Michael Feathers, who wrote a book called Working Effectively with Legacy Code. I guess it's a little bit dated now. It came out in 2004, but it's quite good. And the algorithm, as he proposed it, is to identify change points, find test points, break dependencies, write tests, and then make changes and refactor. And we walk through each of those steps and explain what Michael Feathers means by those. Although, of course, to get the full treatment, you should just read the book. This is our general approach to all these topics. We'll tell you what the general idea is so that there's a there, and it's a thing, and people talk about it, and there's materials. And then we give you references for books or other resources to really get deep on it.
Alternatively, of course, if instead of reading the book, you could also listen to Software Engineering episode 295, in which I actually interviewed Michael Feathers about this book. So that might be like this little step between
fantastic,
your book,
yeah.
then our episode that really dives into legacy code in a whole episode, and then maybe read the book. And with that, maybe we can also move on to the next topic, because indeed your book covers a few of these topics as a little bit of a broad view to weave it all together. Something else that your book talks about, which I really thought was very valuable as a concept, is defensible programming. What is defensible programming?
So this is, I think, a term that's been around for a while, and people do it oftentimes sort of intuitively, but there are essentially a set of practices you can use to kind of both protect yourself as the author from having to deal with bugs later on, and also to protect the software from unexpected behavior. So there's a whole set of practices around null pointers, for example, and input validation. So especially in untyped languages, you get a parameter passed in and you really have no clue what's in that parameter. So you can assume it's the string you always hoped it would be, or you can expect it to be, anything. There's a whole set of these practices to protect everybody that's involved with the code, and also to handle failures in a more graceful way.
One thing we do in the book is we have these sidebars of sharing our personal experiences or experiences we're very close to that illustrate these points and how this stuff comes about. So if you don't mind, I'll share the one that we have about defensible programming, where I made a big goof that, as far as I know, is still out there affecting people. My first job, I might have been still in my undergraduate at the time, but it was working on this genomic analysis service. This was back when the Human Genome Project was it was fully underway, but it hadn't finished yet. So this is around the year 2000, early 2000s. And we provided an online service for scientists to upload DNA sequences and do something with them, search for stuff. At the time, the way that a lot of scientists, a lot of biologists thought about DNA as strings, they just needed a place to type it, right? So often we expected a text file, right? A text file, there's a standard format for how you represent DNA, all the ACs, T, and Gs. And we explained what the format is, but then of course scientists would go and type it straight up into Word and upload a doc file, a Word document file. My crappy little parser didn't parse that because it expected a text file. And so, of course, internally it threw an error. It tried to read the thing and it didn't work. And what resulted for the user was no results are found. We didn't tell them that there was a problem processing their input. We told them there are no results, right? And so they would then some of them would contact us and say, why were there no results? There definitely should be. And some of them would just go away thinking there are no results. And that goes into their scientific research, right? So it's rather terrible. And of course, my terrible solution to this problem was to put a big icon on the submission form that had a word crossed out with a red line. And that drove down the number of those errors. And so everybody was happy. And, I got an attaboy from my manager for solving it this way. But that's not defensible programming, right? This is avoiding the problem. I didn't write a parser for Word. I didn't throw an error upon receiving this thing to say, don't submit it this way, please submit it a different way. So there was nothing there fundamentally that prevented the error. It was just sort of trying to get the user to not do the stupid thing we were annoyed that they were doing. It was the classic blame the user thing. But the visual treatment worked until they redesigned the website. I'd left the job, and literally while writing this book, I went to check the website. It's still around. The tool is still up. They changed the UI, and that little icon is not there. So on a lark, I decided to type some DNA into a doc file, and I submitted it, and sure enough, it went clean through, and I got 0 results. So it's still returning bad. 15 years later, or 20 years later, it's still giving scientists bad results because I was too lazy to deal with bad input.
Wow, that's a great story. So this is an example of what is not defensible programming. So maybe you also have and why it matters. But I'm wondering if you also have a good example of a pro example of what is defensible programming.
In this case, the answer would have been expect that you will have all kinds of wild inputs from your users, be it, people upload their own kind of file or the data doesn't match, and be clear about your expectations. And either, ideally, of course, you treat everything and you're able to process everything, but silent failure is really the error here, right? If you're going to fail early and tell people what the problem is so that they can address it, This comes up in a wide variety of places. User input is the classic one, but also, services change their APIs and things start timing out. And how are you going to deal with that? What you don't want is a failure and a giant stack trace that's facing the user, right? You want to sort of think about your failure conditions and how to defend against them, because they are going to happen, especially as we start working on web scale stuff.
This is maybe the graceful failing that Chris was mentioning, right?
Yeah, like know that it's going to happen. It won't be the ideal flow all the time.
Yeah. Something else you mentioned in the category of defensible programming is avoiding null values. So how? And maybe also why? Like, how can I not use null values? I have to initialize something. Like how does that work? Can you maybe give some practical examples of why that matters and how to go about it?
Yeah, null is definitely one of those hot topics, especially these days, and among a lot of more of the functional programmers among us. But one of the classic patterns that we see increasingly popular over the past decade or so is using like optionals instead of null. And so the idea there is that you're not or rarely dealing with an actual null value. What you're dealing with is a structure that is called an optional. And it can be either something or it can be nothing. Because of the fact that you are dealing with an actual object and you need to either pattern match or extract the value from it, it forces you through the API to think through both the there's something here path and also the there's something not here path, and to deal with the something not here path explicitly. So that's, I think, a very common one.
So maybe diving into that in more mainstream languages, because it's clear how that would work in Haskell or F#, these pure functional languages. But now in Java or in C, if I want to have an optional or a maybe, how do I do that practically? Do I use a library? Do I write this myself? Do I just use this way of thinking in a data type?
It's not that complex. You can write it yourself. There are also libraries. The way things evolve probably between us talking now and the episode coming out, there might be a new one. There's quite a few. I first encountered this line of thinking through Scala, but Java has since adopted that. Superficially at first, it seems like it's not really different from null, right? You can check if the thing is null, do something, or you can say if the option contains something, do something, right? Like, what's the difference? I can still always get my null pointers up from by calling a get on the option at their own time. The major difference there is that null will throw kind of runtime exceptions if you dereference it wrong, whereas the option won't. That really allows you to deal with the thing within the kind of regular flow versus the exceptional flow.
So you mean if it's not at runtime, what you mean is that it will then fail at compile time if you don't handle it properly, right?
I'm thinking of ways that you can still force it to fail at runtime, because you can still wind up doing something with it where you dereference to null if you really try hard.
In general, yes. If you are properly, there's a big caveat, but if you are properly using, optionals, you should essentially get compile time warnings or errors. Another language I was just dealing with recently is Swift, and they essentially have something like an optional with lets, and you can do an exclamation mark or whatever it is to get the actual value out. And what I found myself doing, and this is for a side project and I was just hacking around, but this is like definitely not the right way to do things, is I would just essentially call get on everything and ignore the other path, the none path, which is essentially the same thing as just pretending that it's a regular object and ignoring the fact that it could be nil. And so if you abuse optionals or ignore their intent, then certainly you can get runtime errors. But if you play by the rules and are diligent about it, you should, for the most part, be in much better shape. And as with everything, and this is a big caveat in our book, like almost everything is gray. There's almost no absolutes in computer science. So it's hard to say for sure. You're always going to be safe if you use optionals, right? And in fact, there's a line of thinking with Java, for instance, where they push you to only use optionals in certain situations. So all of this stuff has a lot of caveats around it. But anyway, at a minimum, if you're abusing it and you understand what optionals are for, it does give you a little pang of shame every time that you cheat, which is the feeling I felt as I was playing around with Swift. So you're at least somewhat aware that you're breaking the rules a bit.
Yeah, and it's this extra level of defense, right? So let's do one more from the defensible programming, because I thought that was such an interesting line of reasoning. Also, as you said in the beginning, this is the type of stuff that you don't learn in school, like literally. So you also say retry smart. What is smart retrying? Is it just an infinite loop of waiting for 3 seconds and doing the API call again? Maybe that's not smart. What is smart retrying?
Anytime something goes wrong, you either have an option of giving up and failing, or retrying or going through some alternate code path, right? And oftentimes, especially when you're dealing with network, the answer is like, hey, let's retry again, at least a few times, right? The most naive approach is you just simply take the call you made and call it again. And there are a number of issues with that approach. So you can essentially DOS a service by, if there is a failure amongst a wide number of services. For example, imagine a machine that is receiving calls sort of at a steady rate, and then it has a hiccup, maybe a garbage collection or something, and it's offline for a second. So now you've accrued a second's worth of RPC calls amongst all of the upstream services that are going to call it. So when it comes back online, if they all are just immediately retrying, then you now get this wave of RPC calls all coming to this service. And then, of course, it GCs again because now there's a ton more calls than it expected. And so you get this kind of cascading effect. One of the things we talk about in the book is like telescoping back off or exponential back off, or even just a random sleep where when you retry, you don't just immediately retry, but you pause for a little bit of time and maybe introduce something called jitter, which is like essentially a random wait or a bounded random wait where you say, I'm going to wait 2 plus or minus 500 milliseconds, something like that. So that is 2 seconds plus or minus 500 milliseconds. And then maybe you telescope back. So it's, maybe it starts at 50 milliseconds, then 100, and then 200, then 400. You're not banging away on things. Something else that we talk about in this area is item potency. If the RPC call you're making is incrementing a counter, for example, and you are retrying your call, that is not an item potent operation. So if the call was successful, but the network timed out, you don't really know that the counter was incremented. So if you just naively retry, you are now double counting or triple counting or quadruple counting. You might need some kind of item potent operation. And for that, you could use something like a ID, the incremental ID or UID to allow the server to essentially deduplicate the calls that you're making. So this is all network focused, and this is all sort of retry focused. The retry stuff, I think, applies writ large within your own applications when you're dealing with disk, when essentially anything that's not in your nice little cocoon of immediate code.
Yeah, and of course, this is where we do get into a fairly active area of computer science research, proper computer science research on distributed systems, and there's things like CRGTs and all kinds of other things. It is the case that for like undergrads or bootcamp graduates, they often don't see that stuff, and they kind of run into it much earlier these days when everything is a service and you're talking to all kinds of things online. People who haven't taken the graduate course on distributed systems wind up building distributed systems without realizing that they're doing that. And ideally, they would go full on and learn the distributed systems course material, but as is, at least knowing that networks fail, you should expect that the network will fail. It will not just stay up. You should retry. You shouldn't retry forever. How to do it in a nice way. Right? There's some basics that we just want to make sure everybody generally knows. And then for the more advanced concepts, of course, there's a whole wealth of material there.
I just want to plug an old coworker of mine wrote a book that's pretty widely known as sort of becoming canonical at this point. The Designing Data-Intensive Applications from Martin Kleppmann is sort of like the reference book for a lot of the distributed system data-intensive stuff. So I highly recommend that book if, as a listener, you're into this subject. Or, for that matter, building microservices or actually dealing with stuff on a daily basis. There's just so much there.
Yeah, that's a great tip. We will definitely put a link to Martin's book in the show notes. Let's move on to a different topic then. Something else that your book talks about is testing. Specifically, you distinguish different types of testing, the different uses of testing, I should say. So what are different ways in which testing is used in a project?
Yeah, so there's all kinds of ways that you can test. There are methodologies where you write tests in order to validate your own code as you go along and encourage some best practices. There's unit testing, which is sort of validate that your logic is correct. There's integration testing, validate that the various components of your system work well together. There's acceptance testing, which is sort of more about contracts, right? Like if a third party says, give me software that does X, Y, and Z, then acceptance testing is them checking X, Y, and Z and signing off that you delivered the thing you said that you will deliver. There's a variety of different tests. One common mistake is all the tests go into one bucket, and then you wind up in a situation where tests that you need to validate that the small changes you're making aren't breaking things, should be really fast. But if you're running really complex integration tests that you need to run before you ship a version to production, they tend to be slow and they tend to require a lot of setup. So you kind of slow down your whole development cycle, and it's a very easy trap to fall into. So we talk a little bit about that sort of thing and different kinds of tests. There are lots of different philosophies on testing. There are some people who say, actually, don't bother with the unit test, just write the integration test because that's what the user sees. There are some people who really advocate, covering everything with tests. We suggest that it's easy to go a little bit overboard with that and to test the wrong thing. It's a very deep topic, what the right test is, and sometimes controversial. This is probably the single chapter that we get the most feedback about where they say that we got it wrong.
Yeah, I can imagine.
There's quite a few different philosophies, and we're actually, believe it or not, we're fairly aware of them, and we kind of had to choose one that seemed to be reasonable for a beginner.
One of the things as we were writing this chapter that we went through is we thought it would be great to provide some examples. Here's unit tests and here's integration tests in the wild. And so we went out and we looked at a bunch of open source projects, some of which we work on. And of course, what you discover in the real world is that, one person's unit test is another person's integration test. And some people have, integrations tests that are actually acceptance tests. And so I think one of the things we highlighted in this chapter is you got to be a little bit pragmatic and flexible about when to use these things, what they're called. Don't be too dogmatic about it. The most important thing is you're testing your code and validating that things are working. And so, very frequently you'll find integration tests that run as part of the unit test suite that might or might not be okay depending on the situation. It's just a very messy area in terms of just the naming hierarchy and when things get implemented and where they line up. The thing we wanted to highlight for the new software engineer is it's common that things are messy, and it doesn't mean you're a bad software engineer if you're doing things in a slightly messy way. It also doesn't mean other people are a bad software engineer if, you're looking at, for I think one of the projects, I won't name the project, but we looked at it and they had all their integration tests kicking off locally, and they were doing remote calls to cloud services and stuff. And so just to run the unit test suite involved installing service accounts for various cloud providers and stuff. And that's a little bit on the not great side of things. Like I said, you have to be somewhat pragmatic about dealing with this stuff.
One of the points that we make about this observation is that, and these software projects are very impactful, very useful, have affected thousands of engineers in a good way, made a lot of people much more productive. So let's not be too dogmatic about these things. When you see something like that, that doesn't mean, oh my God, this is terrible. It means, oh my God, this has actually been a collaboration between many different people with a lot of different backgrounds. It's been evolving. That said, if it's slowing you down and if it's creating problems, fix it.
Yeah, I was going to say this is actually, I think, good advice, because you are right that in many areas of software development, but specifically maybe in testing, you do have these different camps and there's just no way to get it right. So I do think, especially for junior developers, it's great to hear sort of the voice of the middle that, yeah, it's fine. If one of your unit tests is actually also an integration test, then it's not you're done as a professional. This sometimes happens. So I do think that that makes sense as an advice specifically at that level. Yet another topic on the book. The book really is a rich collection of all these topics that matter for professionals. Something that you also talk about is code reviews. Specifically, you coined this idea that for me was new of doing a walkthrough with a code review. So what is a code review walkthrough?
The general idea here is a lot of the time these days when people do code reviews, it's make a change, put it up on GitHub, GitLab, whatever your tool is, and then somebody else looks at it. So it's asynchronous, and we give a bunch of tips for how to do this well in a way that you critique the code and you don't critique the people, so it doesn't feel personal, it doesn't feel like an attack, how to write feedback, how to process it, etc. But it's also the case that sometimes the change is big enough that sort of a little blurb that says, I'm fixing a thing, isn't sufficient to really get people to understand it. A lot of the time, this is, I guess, just how humans are, right? You put up a 20-line code change and you get 5 comments. You put up a 20,000-line code change with all kinds of things in there, and you just get to ship it. They couldn't, you can't process that. So for larger changes, sometimes when you're doing really structural stuff or is just fairly intricate, we do recommend that you just grab time with a colleague and walk them through what you're doing. You say, here's what I'm doing over here. Here's why I needed to modify that library. And here's, a different way of thinking about it. And you just really give them rich context about what you're doing and why. And then they have the appropriate context to give you feedback on the code changes.
The other thing I would add is oftentimes we'll get a gotcha of well, you're just not supposed to ship large pull requests. Anything over, some number of lines is a no-no. And so if you break it up you'll never need a walkthrough or an in-person discussion or even a virtual discussion. And I think there's different kinds of large. So there's large in terms of number of lines of changes, but there's also large in terms of like mental capacity to understand the complexity of what's going on. So for example, you might have I'll give you a real world example. We were refactoring a system at my company, which deals with money. And so this system is our ledger. It's responsible for tracking. It's a source of truth for the money movement at the company. So it's kind of a big deal. And we were editing some of the logic in a state machine that was controlling, it was essentially a coordinator amongst a number of machines that were tracking payments. And so this is like a very sophisticated piece of logic. The code is only 500 lines long or so. And it's like this loop that's doing a bunch of stuff based on events. The change itself, might be 40, 50 lines of code, but getting it right and understanding all the edge cases and what's going on, in addition to the testing and stuff, the whole team needs to know about this change. And it really needs to get explored in detail and discussed and really analyzed and thought through. And so setting up a walkthrough for a change like that is hugely beneficial versus, blasting out the pull request, providing a design doc, and sort of walking away and waiting for comments. A lot of stuff, especially remote now, it's important to have real conversations where you can trigger some of these thoughts that might not happen in isolation.
Yeah, I want to dive a bit deeper into that topic because this doesn't really seem to fit the GitHub flow. So there is a pull request and then comments happen asynchronously, which is also nice if you work in different time zones. So how do I do this? Do I plan something like this? Or is this something, you're discussing on the pull request, at one point someone says, hey, maybe we need a walkthrough? Or do you have like guidelines if there's more than 100 lines, then maybe we should... How do I fit? I love this idea. How do I fit this into my project?
I think both things happen. So sometimes if the asynchronous discussion on a pull request gets maybe a little acrimonious, or two people are just not understanding each other, or it's sort of, well, you can do it my way or you do it your way, I don't really care. Like that kind of conversation starts happening. Maybe that's the time to actually have a little face-to-face, virtually or physically, conversation that resolves these things much more generally, amicably, and quickly. It's easy to lose tone and to not understand where people are coming from when you're just exchanging the text messages. So that's one. When sort of things feel like they're starting to go south, just take a pause, find a time to sync up in person. And then the other is when you know that there is this kind of rich context that everybody needs to understand, either because the change is sophisticated, not necessarily large, but maybe even subtle, and there's subtleties there that upon just reading the code, somebody might not get, and you need them to know. This is probably not something that somebody fresh out of college should be doing, just that kind of change. But if you think there's something subtle going on, right, like tell people. When you know you're doing something that maybe is what I'm actually doing is setting up for 7 more pull requests that are also going to be small changes, but let me tell you where I'm going and let's sync up. Then you do it preemptively. Different teams have different processes around that. Like maybe there's a standing sort of design discussion meeting, or maybe you do it ad hoc.
I just wanted to jump in on the open source side of things. It's one of those things where I think you'll find a lot of people are definitely willing to take time and have in-person chats, but it's not something that is, I think, really part of the culture right now in a lot of ways. But I've definitely had in-person chats on a number of different open source projects, Airflow, chatting with people, Amundsen data catalog that we use. And so oftentimes if you ask, he's like, hey, can we hop on a Zoom or hop on a Google video chat, modular time zones, it's a great way to discuss the change, but also build sort of relationships with the community. In some ways, I would just encourage people to try it. You get a lot more engagement than you expect. And then it is also quite useful. So I totally buy it is not part of the culture, not part of the Git flow, GitHub pull request cycle, writ large. I think some of the more mature projects, when I say mature, I mean in terms of like process. So projects that are under Apache or CNCF like that, and have multiple companies working with them, they're I think more apt and more likely to have, community meetings, meetups, weekly sync ups, stuff like that. In those cases, it's a little more common. But, your average like Ruby gem on GitHub that's maintained by, maybe a college student or somebody, that's far less likely. But I don't think that's because they're unwilling to do it. It's just something that I think hasn't really sort of happened as a like mainstream thing. But it's really beneficial and it does work.
Awesome. To close that topic, if you do want to know more about code reviews, we had a show on that as well. Show number 400 with Dr. Michaela Greiler goes into code reviews a lot deeper. But this book has so much more to offer us that we could talk about. One of the things, this came up very early in this episode already, is logging. So logging is something that maybe you don't learn in school. Can you give some ideas of what are practical best practices that your book covers?
I've spent an unbelievable chunk of my life dealing with logging, being sort of in the data field, which is not something I would have predicted coming out of undergrad. There's a couple of things. One, I don't want to overgeneralize, but frequently when folks do their programming outside of kind of a professional environment, logging is just writing some stuff to standard out or maybe to some file, right? It's print line, I got to this point and I'm doing the next thing. And that's completely sufficient and fine. And then you get into industry and you realize people are using logging libraries that have logging levels, and you need to understand what those levels are. And it's just one of those things that is pretty fast to learn, but nobody bothers to teach you. We bothered to write it down so that you can read about it. What do these log levels mean? I mean, of course, it's documented, right? They can look it up on the web, but you need to know to look it up. What do these log levels mean? What to put in where? A little bit of kind of philosophy on, what is a warning and what is info and what's the difference between a warning and an error and a fatal, that sort of thing.
So maybe we can dive into those topics a little bit more. So what are different log levels for people in the audience that might not be familiar with that?
See, that's where I need to pull out the book and check.
That's okay.
Let's see. I'll take a crack at it while you're looking.
Go ahead.
Fatal, error, warn, info, debug, trace. I believe that is the worst to best level. And when I say that, every framework or language has its own verbiage. So some of them, might get a little fuzzy there, and not all of them have fatal, and not all of them have error. That's generally what you'll find is that sequence, I believe. I would just say we also, in addition to the levels, we talk quite a bit about sort of best practices. So how to keep your logs fast, where logs go, like are they going to disk, are they going remote, redaction and not logging passwords, email, PII, which is personally identifiable information like emails and usernames and stuff. There's a lot that goes into good production grade logging that is not obvious even from the error API that you're calling. Like one of the most common things you'll see is like someone will call the log info and they'll have their string that they're logging, and then they'll concatenate a dynamic value to that string, like starting server with port and then, plus and then the port number, right? And string concatenation is a slow operation. And if you are not logging at the info level, you are burning CPU on something that is not useful. And so there's like all kinds of practices and little tricks that are not obvious that by tweaking the way that you're logging things, you can really get a lot more performance out of your application. And I've been in many situations where I've done performance analysis, and in the tight loop, the trace log line that is just never being read by anyone is taking up like 80% of the CPU cycle. So there's like a lot of gotchas that are just not obvious with logging at all.
I used to joke that eventually my retirement gig would be a string concatenation consultant, where I would just go into people's code bases and fix how they use strings and make their code run for 10% faster. Because there's so much of that out there. And you can basically do it with a shell script, right? Just like fix people's stuff. One practical tip, printing stack traces. They're usually multi-line. And once you go into kind of industrial deployments, there are usually systems that suck up all the logging that different services do and make them available for search, etc. But they tend to work on a line-by-line basis. So if your message isn't contained within a single line, it gets broken up, and good luck reconstructing back your 27-line stack trace that has been sort of broken up into 27 separate messages and mixed together with similar logs from all the other deployments of the same service. And now they're all kind of shuffled together, right? So there are plenty of ways to deal with that. Structured logging, there are loggers that will log things in JSON format for you and capture these sorts of things. It's a little bit of work initially, but then it just saves you a ton of time if you're using one of these like elk stack type log processors.
Nice. Yeah, those are really nice practical tips and advice for logging, which is indeed a topic that you would think in theory it's fixed, but in practice it can lead to so many issues. we're nearing the end of the episodes. Is there like one topic that you really like about the book where you're like, oh, I have this nugget of advice that I really want to share before we wrap it up?
The section we have on handling dependencies and understanding versions, it is really not something people talk about enough. And it's one of the biggest time sinks and sources of unexpected problems that I see people run into. And not just juniors, right? It's really important to understand the dependencies that you're introducing, what those libraries are, what the versions mean that you depend on, and what will happen when versions change, whether or not they will change on you without you knowing it because of the way you've instrumented the dependencies, what 1.2.7 going to 1.2.8 means versus 1.2.7 going to 2.1.2 means. So like sort of the major, minor type versions and what to expect from that stuff.
So what do you have some practical tips there? So knowing what version numbers means, that's definitely a tip, but are there any practical advice or maybe a nice anecdote you have about dependencies that people can learn from? I think Chris has an idea here.
Again, there's no 100% guidance, but pin your version numbers so that things do not change underneath you is something that I am fairly dogmatic about. And there are definitely competing philosophies and people that you think you should, pin major and minor, but not the patch version. There are people who think that you should always pull in the latest stuff. But I've just dealt with so many problems that stem from like, we're pulling in some open source project and either we have not pinned, and by pinning, I mean setting an explicit version number on your dependency such that you will always use that version versus an unpinned version number where you essentially leave it to the build or the build system to pick what the right version number is. And in cases where there is a new version available, it will pull that version in for you. That behavior leads to all kinds of exciting stuff during CI and build time where things that worked and have not changed suddenly stop working for a variety of reasons. That class of problems is so maddening to deal with, and it saps energy, and it ruins the fidelity of your tests. It's such an insidious problem.
I have experienced this type of thing myself, and it is so terrible because you have this commit and you're like, okay, before this commit, it works. And after this commit, it fails. So I'm going to read this 100 times, right? Because this is the offender. And if it's not the offender, someone else that I have no control over has certainly decided to remove a feature I was depending on.
Even worse, you decide, okay, I'm going to revert this commit, and you revert it, and it still doesn't work. That same checksum used to work.
Yeah. I think this is really good practical advice. This is like the stuff from the trenches, so to say, right? That you don't teach this in schools or in universities. You would say you have to learn this by doing it, but of course it's way more efficient than experts, senior people like you share this advice and put it in a book.
One other thing I wanted to throw out there, I think in line with your question about if people walked away with one thing that we could upvote into their brain, what would it be? It's compatibility. And this is kind of adjacent to the dependencies, but really understanding forwards and backwards compatibility and what these different names mean. I think whether you're dealing with data or APIs, whether that's a library API or a microservice API that's remote, understanding what it means when you add like a required field or when you delete a required field or when you change a data type from, int to long or int to string, like what that is going to do to the upstream and downstream dependencies of you in a professional environment. It's so important to understand that you're working within a team and you're going to affect other people's code. And it's not something that is at all obvious. Like it seems so benign to just add like, oh, I need a field in my database or I need a field in my API. I'm going to set it to required. And then that simple change can bring down the whole website, the whole microservice, the whole application can crash. So I would say understanding compatibility is definitely something. And we cover that, I think, in the evolvability chapter. We talk about that in some detail. So that would be my pet guidance.
Almost circles back to Dmitry's example of the word button, right? That if you make something, it is not always clear how it's going to be used. The interface around might change. So then you in the software, you still need to be prepared against anything because you can't depend on other people. You don't know like what you depend on and who might depend on you if you're building a library or framework. So,
have you ever really been happy with your project management tool? Most are too simple for a growing engineering team to manage everything or too complex for anyone to want to use them without constant prodding. Shortcut, formerly known as Clubhouse, is different though because it's worse. Wait, no, we mean it's better. Shortcut is project management built specifically for software teams. It's fast, intuitive, flexible, powerful, and many other nice positive adjectives. Let's look at some highlights. Team-based workflows. Individual teams can use Shortcut's default workflows or customize them to match the way they work. Org-wide goals and roadmaps. The work in these workflows is automatically tied into larger company goals. It takes one click to move from a roadmap to a team's work to individual updates and vice versa. Tight VCS integrations. Whether you use GitHub, GitLab, or Bitbucket, Shortcut ties directly to them so that you can update progress from the command line. The rest of Shortcut is just as keyboard friendly with their power bar allowing you to do virtually anything without touching your mouse. Throw that thing in the trash. Iterations planning. Set weekly priorities and then let Shortcut run the schedule for you with accompanying burn down charts and other reporting. Give it a try at shortcut.com/SERadio. Again, that's shortcut.com/SERadio. Shortcut, again, formerly known as Clubhouse, because you shouldn't have to project manage your project management.
Where can we read more about your work? Like, where can we find the book? We will make sure that we put everything in the show notes, but I just want to give you an opportunity to shout out to your website or your Twitter or whatever you want us to link to in the show.
Yeah, so theMissingReadme.com is the website for the book where you can look at it a little bit more. And of course, it's available on Amazon and everywhere else where books are sold. If people read it, we'd love reviews. We'd love to find out what folks think about it. As you, of course, know, reviews are very important for the authors to after we put the book out there in the world to hear back. I am on Twitter at SquareCog.
Yeah, and I'm on Twitter at Riccomini, so C and then my last name. The website has that controversial chapter. The test chapter is available for free. So if you go to theMissingReadme.com, you can download that PDF and come after us on Twitter now that we've given you our Twitter handles.
Nice. Awesome. So we'll make sure to add those links to the show notes. Thanks again for writing this wonderful book, and thanks for being on the show today with me.
Thanks for having us.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.